So we are using the same formula. But instead of finding the work done is given to you. You need to find out the coefficient of friction. Right. You read this 5.5.2.
The man pushes the same 50 kg sled over level ground with a force of 1.75 times 10 to the power of 2 Newton exerted horizontally, moving it a distance of 6 meters over new terrain. If the net work done on the sled is 1.5 times 10 to the power of 2 joule, find the coefficient of kinetic friction. Repeat the exercise with the same data, finding the coefficient of kinetic friction, but assume the applied force is upwards at 45-degree angle with a horizontal.
Okay, so this example is exactly the same as the previous example. They only change the numbers, right? Over new terrain. Now, over new terrain means it's a different type of surface, so the coefficient of friction is different now. That is what they're trying to say, right? And also this time, instead of giving you the work done, instead of giving you the coefficient of friction, they give you the work done, the net work done. Net work done is 150 joule. So if you don't have to find the work done, what they ask you to find? They ask you to find the coefficient of friction. They ask you to find the coefficient of friction. We are going to apply the same formula. We are going to apply the same formula. So before I go on, I show you the formula. So we are going to use this formula. F equals to mu n. Work done equals to F times T. But there are two types of work done. One is the total work done. Another one is the work done against friction. Another one is the net work done. So there are three types of work done. One is the work done by friction. Second is the total work done. Third is the excess force, the net work done. Okay, so okay, so now we start. They ask you to find the coefficient of friction. Okay, and what is given is the net work done. So can you form an equation involving the net work done? Okay, so you look at the diagram over here. You look at the diagram over here. There are two forces here, 175 and the frictional force mu m. 175 and mu m. So you are given the net work done is 150. So what you need to do is you try to relate these three things: the the applied force, frictional force, and the net work done. Okay, we try to relate these things. So I'm going to write out an equation here, right? Okay, so we want to find the frictional force first. The frictional force is F equals to mu n. Mu is what we don't know. N is the same as mg. Right? N, the normal reaction is the same as mg. M is 50 kilogram, G is 9.8. The net force is the applied force minus the frictional force. The net work done is this net work multiplied with the distance. Now this is the formula that we are going to use. The net work done is the net force multiplied with the distance moved. One more time. We are going to relate this net work done with these two forces here. we are going to we are going to relate the net work done with the two forces here. How to relate them? This is the relationship. This is the relationship. The net work done is the net force multiplied with the distance moved. So earlier on, I've explained to you how to find the the net force. So the net force is applied force minus the frictional force. Net work done is the applied force minus the frictional force multiplied with the distance. That will be the net work done. So now I'm going to substitute what is given into this relation or into this equation. Okay, the first one is net work done. Net work done is given 150 joule. So I write down, I write down here, this net work done is 150 joule. Applied force is 75 here, applied force 75. So applied force I replace with 175 newtons. Frictional force I found out earlier here. Mu times 50 times 9.8. And the distance moved also from here. Okay, distance moved is 6 meters. Okay, so this is what I mean by given the forces and the work done, we should form an equation, right? An equation for the net work. The net work equal to net force times the distance. Net work, net force times distance, right? Net force is applied force minus the frictional force. So from this equation, we are going to find the value of mu. From this equation, we are going to find the value of mu. So what is the value of mu? The 6 you move over first. 6 you move over first, 150 minus, divide by 6. Then this one, the frictional force move to the left hand side. It's 150 divided by 6 move to the right hand side. So we have this. So you divide by 50 and times 9.8, you get the coefficient of friction. Okay, so you can do this or not? Can you do this on your own? I let you try over here, the second part.